All right, so we got a couple things here. We're just solving systems of equations in this one, but just a quick reminder that CPM was really nice to have some links to help us out with this stuff. So if we're needing some more practice with solving linear and quadratic systems, there's a lot of practice problems in this situation here. So okay, let's do this one here. We're solving the system, meaning we got to find what, in this case, P and Q are equal to. Or if we were looking at it in terms of a graph, then where they cross. And if you notice this here, there's a P squared on this one, and then only just a regular P. So really I'm having a parabola and a straight line. So my expectation is I'm going to have two different P values and two different Q values. So that's just to think about before we even get started. So first thing I'm going to do here, looks like I'm going to go ahead. I want to solve for, I don't know, let's call it P, I guess. Well, yeah, solve for P, sure. I'm going to subtract 2Q from both sides here, and I got P equals 4 minus 2Q. Now I'm going to plug that back in to this equation and do a bunch of math. So 4 minus 2Q squared plus 2P, 2 times 4 minus 2Q plus Q equals 24. Now I got to do some math to simplify this, so use the handy old box. 4 minus 2Q, 4 minus 2Q, 16, negative 8Q, and 4Q squared. So now I got in here 4Q squared minus 16Q plus 16. I will also distribute that to get 8 minus 4Q plus Q equals 24. Lots of math in this one because I chose to solve for P, but now I'm just going to combine like terms. So I got 4Q squared. Now I got negative 20, what is that, negative 19Q. And then I got plus 24 equals 24. And now I'm going to be solving this one. So I'm going to be subtracting 24 from both sides. I just get 4Q squared minus 19Q equals 0. And so when I'm going through this one here, when I solve this, I need to find the greatest common factor, and this is going to be Q. So I got 4Q minus 19. And now I just solve. So this side here tells me that Q is going to be equal to 0. This side here, 4Q minus 19 is equal to 0, so I actually have to do some math. 4Q equals 19, divide both sides by 4, so Q is equal to 19 over 4. So there's my two solutions for Q. Now don't forget, we have done a lot of math, but we still got to do some more because I have to plug in those values back into my original equation here. So I'll do it up here in red, where I know Q is equal to 0 and 19 over 4. I'm going to plug those back into the easy one here when I simplified this to 4 minus 2Q. So I'm plugging in Q to this. When Q is 0, I got 4 minus 0. So P is equal to 4. And when Q is 19 over 4, I have to actually plug that in. 19 over 4. Which these cancel. Give me 4 minus 19 over 2. And this is really 8 over 2. So I get my final P value of negative 11 halves. So my first is 0, 4. Then it's 19 over 4, comma, negative 11 over 2. All right. So for the second one here, I'm going to solve for y by adding y to both sides and subtracting 2. So I get 2x minus 2 equals y, and now I'm going to plug this into my top equation here. So x squared plus 2 times 2x minus 2 equals 1. I distribute here, and I got x squared plus 4x minus 4. But I want to solve and set this equal to 0. So I'm going to subtract 1 here and get x squared plus 4x minus 5. Now I will factor this, and if I factor this correctly, I should get x plus 5, x minus 1. So my two solutions for x are negative 5 and 1. Now I got to plug that back in to find my y values. So I got y equals 2 times negative 5 minus 2, which would be negative 12. And then I plug in 1, and I get 0. So as coordinates, my two solutions are negative 5, negative 12, and 1, 0.